Kafka producers are independent processes which push messages to broker topics for consumption. And should producers fail, consumers will be left without new messages. And on your screen, you're going to see some of the most useful producer metrics to monitor to make sure that there's a steady stream of incoming data. So let's investigate some of the key producer metrics and what they do. Look at your screen. This metric here, it reflects the ratio of data compression in the batches of data that the producer sends to the broker. A higher compression rate that indicates greater efficiency. Now, if this metric drops, it could indicate that there's a problem with the shape of data or that a rogue producer is sending uncompressed data. For producers, the response rate, it represents the rate of responses received from brokers. Brokers respond to producers when the data has been received. Now, depending upon your configuration, received could have one of three meanings. It depends on what your definition of is thing. When we say received, it could mean that the message was received but not committed. In other words, request.required.ax equals 0. Or the leader has written the message to the disk, ax equals 1. Or the leader has received confirmation from all the replicas that the data has been written to the disk. And this is request.required.ax equals all. The producer data is not available for consumption until the required number of acknowledgements have been received. So if you're seeing low response rates, a number of factors could be at play. And a good place to start is by checking that request.required.ax configuration directive in your broker. Now, choosing the right value for that request.required.ax, that's going to be entirely use case dependent, totally up to you, whether you want to trade availability for consistency. You should consider rate limiting if there is an issue here. The request rate is the rate at which producers send data to brokers. Of course, what constitutes a healthy request rate, that'll vary drastically depending on the use case. But keep an eye on the peaks and the drops, as that's essential to ensure continuous service availability. If rate limiting is not enabled, in the event of a traffic spike, the brokers could slow to a crawl as they kind of struggle to process a rapid influx of data. Let's go to the next one. The average request latency, that's a measure of the amount of time between when Kafka producer.send was called until the producer receives a response from the broker. Okay, so received again, in this context, it can mean a number of things, as I explained earlier on the response rate, right, when I talked about that. But a producer doesn't necessarily send each message as soon as it's created. The producer's linger.ms value, that determines the maximum amount of time it will wait before sending a message batch. And this potentially allows it to accumulate a larger batch of messages before sending them in one single request. Now, the default value of linger.ms is 0 milliseconds. So setting this to a higher value can increase latency, but can also help improve throughput because the producer will be able to send multiple messages without incurring additional network overhead for each one. So if you increase linger.ms to improve your Kafka deployment's throughput, you should make sure that you monitor the request latency to make sure it doesn't rise beyond an acceptable limit. Because latency has a strong correlation with throughput, it's worth mentioning that modifying batch.size in your producer configuration, that can lead to significant gains in throughput. Determining an optimal batch size, that's going to be largely, again, use case dependent. But a general rule of thumb is that if you have available memory, you should increase the batch size. And keep in mind that the batch size that you configure is an upper limit. Okay, and note that small batches involve more network round trips, and this can reduce throughput. One of the things that you might want to consider as well is calculating your average message size. And that'll help you with setting the linger and setting the batch size. Okay, let's move on to the next one. Okay, so what you see on your screen is directly related to network throughput. Just like with the Kafka brokers, you want to monitor your producer network throughput. Observing the traffic volume over time, it's essential for determining whether you need to make changes to your network infrastructure. Monitoring the producer network traffic will help to inform decisions on infrastructure changes, as well as to provide a window into the production rate of your producers and to identify sources of excessive traffic. And in most cases, it'll be an application. Let's move on to the next one. High I/O. Your producers cannot get what they need fast enough. That's what you're going to notice. Producers are generally going to do one of two things. A producer is going to wait for data, and a producer is going to send data. If producers are producing more data than they can send, then they end up waiting for network resources. But if the producers are not being rate limited or they're maxing out their bandwidth, then the bottleneck becomes harder to identify. Now, disk access, it tends to be the slowest segment of any processing task. Checking I/O wait times on your producers, that's a good place to start. Remember, I/O wait represents the percent of time spent performing I/O while the CPU was idle. So, if you are seeing excessive wait times, that means that your producers cannot get the data that they need fast enough. If you're using traditional hard drives for your storage backend, you might want to consider SSDs. Now, take a look at the screen to see what I mean here. To use network resources more efficiently, Kafka producers attempt to group messages into batches before sending them. The producer is going to wait to accumulate an amount of data that's defined by the batch size. And the batch size is 16 kilobytes by default, but it will not wait any longer than the value of linger.ms, which again is defaulted to 0 milliseconds. So if the size of batches sent by a producer is consistently lower than the configured batch size, then any time that your producer spent lingering is wasted waiting for additional data that's never going to come. So consider reducing your linger.ms setting if the value of your batch size is lower than your configured batch size.